So this is the second session. I'll just give a bit of preamble for a couple of minutes to make sure everybody's logged on and with us. Differentiation. Now, it's not magical. It's something that's new to year 12. When I was in 1978, when I did this, I was in year 11. We did it as a year 11 topic. So it's not actually difficult. The thing to remember is what it is aiming to do. All it's aiming to do is to work out the gradient of any function at any point. And that's really what differentiation is. And sometimes we lose sight of that with the nuts and bolts of it, with the mechanics of actually differentiating. We forget what it is that we're doing. The other thing I'll say is, where have I got the lesson from? I sat down with a blank piece of paper and I thought, well, I use these three documents here. These are all from Mathmateg, and I talked about Mathmateg last week. If you haven't been on it, go on it. And there were three sections in differentiation. First of all, differentiation from first principles and differentiation of expressions. So this question here says from first principles, but here it's giving you find dy by dx. Differentiate, not from first principles, just differentiate. Okay, and then tangents and normals. Again, a big section on tangents and normals. We will be sending these out to you as well after the session. So these are WJC questions from 2005 to 2019 and stationary points. And the same idea again from 2005 till 2019. Okay, so I've got all of the examples from WJEC. Okay, now we'll do it as I did before. So these notes will be available to you once the session's finished. I assume that worked from last week. You can have it's quite good if you've got a piece of paper and you try and work through the solutions, or at least start them off. Okay, you won't be able to finish them. We won't have time for me to stop and let you do a whole question. But if you can start it off, and then I'll show you what it is. Now, so my introduction, what is it? A method to find the gradient of a curve at any point on the curve. And it's a big application for rates of change. You may have seen that. It will certainly crop up in your mechanics. Now, differentiation from first principles. And this is what I call a bookwork question. By bookwork, I mean you simply follow the method. Understanding goes out the window. Okay. And there are two ways to present it. You can let a small increase in y be delta y, and then you get a small increase in x, delta x. That's the way I do. I know some teachers let a small increase in y be h. And the method is exactly the same. The first equation is the function. The second equation, you put y plus delta y for the y's, you put x plus delta x for the x. You expand, you subtract the equations, you divide by delta x, then you put the limit as delta x tends to naught of delta y over delta x, which is dy by dx, and you've differentiated from first principles. I'm not going to go through it any more detail than that. It's bookwork. There are plenty of resources you could find where you could do that. But this, where I teach it, I teach people how to differentiate from first principles. We spend an hour and a half on it. They have a homework, they do a load, and then we get the rule, which is if y is x to the power of n, dy by dx is n x to the power of n minus 1. And you might see this in function notation. So rather than y, we have f of x is x to the n. And the notation for the differential of the function is f dash x. F dash x equals nx to the power of n minus 1. But you don't remember it like that. You remember what I've written in red at the bottom of the page, which is you multiply the coefficient by the power and reduce the power by 1. So here's the first question for you to try. Again, I'm only going to give you 1 minute. Have a try at differentiating the first one. Have a try at just differentiating that. I'll cover up the second one. I'll only give you 1 minute. Okay. Right, now the first issue here is the fractional power. There's usually something to do before you actually differentiate. Okay, so y equals minus 2 x to the power of 5 plus 4x minus x to the power of minus 2, which is why we've done the work in indices at the start of your A-level course. Okay, once you've got everything in that form, you can now differentiate. Next thing, if I disappear from view, don't worry, I've got to keep looking here at what we're doing. Now, quite often we use an equal sign. Well, the equal sign means what I write here is the same as the line above is the same as the line above. But if I'm going to differentiate, it's no longer y, it's dy by dx. So when you differentiate, make sure you've put that you differentiated. Equals minus 10 x to the power 4 plus 4 plus 2 x to the power of minus 3. Okay. And if you then wanted to, I mean, that's perfect. That's all you need to do. You could write minus 10 x to the power 4 plus 2 over x cubed. Go back to the fractional form. Right, next one. Have a quick go at this one. Again, 1 minute and I'll do it. 1 minute and I will do it. So think about this. Ask yourself this question with these. Can you differentiate it as it stands? If not, what can you do to get it to a stage where you can differentiate it? So 1 minute. And you probably realised it's not a polynomial, you've got brackets in there. So your first job is to get it into what's called a polynomial. A term, a term, a term, a term. So x squared times, and expand the double brackets using the box method, which would give me 3x minus x to the power 4 minus 12 plus, plus 4x cubed. Be careful with the signs, right? So I've just done face, foil, boxes, whatever you do it, and then multiply by x squared, and I get 3x cubed minus x to the power of 6 minus 12x squared plus 5x to the power 5. And now I can differentiate dy by dx equals 9x squared minus 6x to the power 5 minus 24x plus 25x to the power of 4. Simples. Okay. Notice all the work goes on there. So the differential algebra, the differentiation itself is a very simple process. Now then, this is slightly different as you do a bit more. Okay. Now, with this question, in year 12, it's got to simplify. Okay, now I would think, what can I do to the top? Well, first of all, common factors. I would remove the common factor for a start. So y equals 3x, because every term has an x in it. Quite often people miss that one. Okay, which then gives me 3x brackets x squared plus 6x plus 8 all over my ruler, x to the power 4. Sorry, x plus 4. And now factorise, which equals 3x, x plus 2, x plus 4 all over x plus 4. If you didn't take out that 3x first, you might well not have the x plus 4. You might have 3x squared plus 12x there. And actually, would you spot that it would factorise out? So now it will cancel. Easy. Okay. Now we still can't actually differentiate it because we've got the bracket. So now we've got to expand that to get me to 3x squared plus 6x. So all that is simply turning our expression into a form that would be able to differentiate it. Now we differentiate. Notice I need to write dy by dx, which gives me 6x plus 6. Another hint, whenever you've done something, whenever you've found something, underline it. Tell the examiner, I've worked something out that might be worth the mark. It makes the examiner's job much easier, but it also lets the examiner know what it is you're trying to do. What were you trying to do when you wrote that? What were you trying to do when you wrote that? Okay, you're going to pick up method marks, even if you do. I mean, listen, you found out last week I made lots of mistakes. I'm not perfect, just more perfect than you lot. That's the only difference. Okay, now it's asking, then go back and read the question. Read the question. It says find the gradient at that point there. So if x equals -2, so tell the examiner, if x equals -2, the gradient dy by dx equals 6 times -2 plus 6, which comes out at -6. Be careful with the signs. There's my final answer. Job done. Differentiating, quite straightforward. Okay. Now, tangents and normals. So those questions were basically, can you differentiate? Oh, just one thing. We're also going to send you at the end of the session, or make available to you, is this sheet here called solutions. Now what I've done, I've written them out already, my solutions. So there are the solutions that you can actually work through and put into your notes. Okay, all there, and it's page by page. So the page 2 solutions refer to page 2, the page 3 solutions refer to page 3. Okay, so that's something you might find useful. Now, this really follows on from last week's work. Quite often we'll want to find the equation of the tangent or the normal to a given curve. So, example, find the equation of the tangent to the curve y equals x squared over 3 minus 4 root x minus 1/3 at the point 4 minus 3. And actually it tells us the form that it wants the equation in. ax plus by plus c equals 0, where a, b and c are integers. More about that at the end. Now, think about it. The tangent is a straight line. We know how to find the equation of a straight line. Y minus y1 equals m brackets x minus x1. Okay, from last week. I know my x1, it's 4, my y1's -3. I need the gradient. I need the gradient at that point, but it's a curve. So differentiating. It doesn't tell us to differentiate. It assumes that you're going to know to differentiate to get the gradient. So y equals x squared over 3 minus 4x to the half minus 1/3. So if I'm going to differentiate and I've got a root in there, you've got to go to fractional powers. Okay. The method is exactly the same though. Differentiate dy by dx is 2 over 3 x to the power of 1. You can put the power in, put it in if you want, don't put it in if you don't want, minus half times 4 is 2. Now then, half minus 1, 2x to the power minus half. Half minus 1 is minus a half. And the 1/3 is 1/3 x to the power of 0. So any constant there will disappear. The constant will always go when you differentiate. So that gives me 2x over 3 minus 2 over root x. Now I always tend to, because I'm not very good at maths and I'm prone to make mistakes, I always want to put that into a root form. Now that's the gradient at any point on that curve, but I know what my point is. Tell the examiner, if x equals 4, so I've found dy by dx, if x equals 4, okay, dy by dx, the gradient equals 2 times 4 over 3. And that is how I tend to get round the signs and all sorts of things of multiplying and not putting x's in. Use brackets. You can use dots if you want. That's just the way I was brought up. Minus 2 over root 4. So that is 8 over 3 minus 1, which equals 5 over 3. And that's dy by dx at my point. So, following on from last week, equation of the tangent. Tell the examiner what you're doing. Equation of the tangent. And the formula from last week. Y minus y1 equals m brackets x minus x1. Okay. M is 5 over 3, the gradient. X1 is 4 from the question. And Y1 is minus 3 from the question. So we go back to the question. It's always worth rereading the question. So when your teacher goes on about read the question carefully, that's what they mean. You've got to keep referring back because there's an awful lot of work here before we're going to use that key point in the question. And now, simply don't make a mistake at this stage. Y minus 3 or y plus 3 equals 5 over 3 x minus 4. It's asking for integers. It's not asking for y equals mx plus c. So I would say 3y plus 9, just multiplying up by the 3 there, and then expand the bracket by multiplying by 5 equals 5x minus 20. Now, there are lots of answers. The one I would go for would be to make the x positive. Don't ask me why. I always do it. So I would say 5x minus 3y minus 29. So I've moved everything to the left-hand side equals 0. If you want to be really clever, you can say 5x minus 3y minus 29 equals 0. If you've got an answer, though, this answer will be perfectly acceptable. 3y minus 5x plus 29 equals 0. Again, you've done what it said. the mark scheme will always say OE, that OE, or equivalent. It's one of the things that teachers always use when pupils copy the mark scheme out, because they always write the OE bit because they think, oh, that's important. Okay, now then, a normal. Normals are not magical. Okay, it's not witchcraft, it's not weird science. The normal is simply the line perpendicular to the tangent. Okay, so find the equation of the normal to that curve at that point. Okay, now first thing is, as soon as you ask the equation of the normal or the tangent, you want the gradient, you're differentiating. Okay, can you ask yourself this question? Can I differentiate that? No. Why not? It's fractional. So here's how I would think of it. Don't be scared of it. Put it in as indices for a start. Put it in as an index for a start. Now, each of those I've got to divide by root x. To divide, you subtract the powers, don't you? So y equals 3x to the half. Divide the powers, x1 divided by root x is 1 minus a half, which is half, minus x to the power of 2 minus a half is 1.5. But you know what? I'd write it as 3 over 2. And top-heavy fractions are always preferred to mixed numbers, unless you've got a very good reason to be mixed numbers. Now, ask yourself, can I differentiate that? Well, yes, I've got a polynomial in x, polynomial, many-term expression, many-nomial terms. So, now I'm going to differentiate dy by dx equals, multiply, now just be careful here, 3 times a half is 3 over 2, reduce the power by 1, x to the minus half, minus 3 over 2, x to the half. Okay, now obviously you can use your calculator at this stage, fine, right? But I haven't got one, so there's always neat ways around things. So I've got a common factor of 3 over 2, don't I? Take out the common factor of 3 over 2, and that is 1 over root x minus root x. So I've just turned the powers into what they actually mean. Okay, and now I've got my point, x equals 4. So dy by dx is 3 over 2 half minus 2. Square root of 4, 2. Okay. So I've now got dy by dx is 3 over 2 times minus 3 over 2. So dy by dx is minus 9 over 4. Now, just be careful. That is the gradient of the tangent. Tell the examiner. I mean, the common mistake is people are so pleased that they've got a gradient, they've forgotten that they're after the equation of the normal. Yes? So just calm down. And the thing is, when you get up to a question like this and you think, well, I've done 6 lines, you're in a bit of a panic, you think you're stressed for time, this is when you make daft mistakes. At the time when you need to be careful and calm and reasoned, you panic. Okay? Now then, the gradient of the normal. Now, by now, the examiner knows what you're doing. It's the negative reciprocal, okay, the negative reciprocal, and then the equation of normal y minus y1 equals m brackets x minus x1. It's not magic, it's not witchcraft, it's just doing the simple things well. M is the gradient, 4/9. x1 is the x value, and if you remember that is 4, it's in the question, and y1 is -2. Well, actually, that question is exactly the same as the one we just did. The only difference is going from the tangent to the normal, and the rest is care and confidence around your algebra. Yeah, the only thing that breeds confidence is practice. So y plus 2, just substituting in, equals 4/9 x minus 4. Now, obviously, I've done literally hundreds of them, and I've marked literally tens of thousands of them because I'm an A-level examiner as well. So I'm very confident with doing it, and I tend not to make many mistakes. You haven't done as many yet, so you're probably thinking it's a bit awkward, but it becomes very much routine. That's the good news. 9y plus 18, just multiplying by the 9, equals 4x minus 16, whichever form you want. But remember, I always say make the x positive. It's just a habit I'm into, okay? And there we have it, the answer. Very simple, very routine, okay? Now, we've only got 13 minutes. Now, I am conscious that there's a lot to get through here, so I'm not going to gabble my way through. If I don't finish by 5, okay, next week we're going to be doing integration. So if I haven't quite finished differentiation by next week, we will finish it off at the beginning of the session, okay? So because differentiation and integration are such huge topics, we can't afford to gabble our way through and not understand. Now, stationary points or turning points are the interesting points in the graph, because at a stationary point, the gradient is 0. So if ever you've got to find a stationary point, you put dy by dx, the differential equals 0, you'll have the stationary point. There are 3 types. The minimum, where the gradient, there's the actual point, the gradient is 0. That's the gradient of the tangent, look, is 0. To the left for a minimum point, the gradient is negative, and to the right, the gradient is positive. Now, your teachers may well have gone through a process by which you drew a little table and worked out the gradient just below the point and the gradient just above the point. Fine. That method works, and there are plenty of occasions, certainly next year, where you have to use that method. But you've probably come across the second differential. You differentiate a second time, and that's d2y by dx squared. If d2y by dx squared is positive, when you put that x value in from there, it's a minimum point. Obviously, for a maximum, everything's reversed. The gradient goes from positive to 0 to negative. So we've got a maximum point, and the second differential is negative for a maximum point. Just be aware, positive is a minimum point, negative is a maximum point. It's the opposite way around to what you might think, okay? And that's a common mistake when I'm marking it, that people do the second differential and then make the wrong decision. So for goodness sake, don't do all the donkey work and then say, oh, it's a minimum when you mean it's a maximum. There is also a point of inflection that crops up certainly in further maths a lot more. And there are two ways around. I've only drawn one way. The gradient is positive, then 0, and then positive again. So the gradient at that point is 0, so it is a stationary point. Okay. Notice it's one case where the tangent goes through the line. So there's a few things there that are weird about the points of inflection. And obviously, a point of inflection is when d2y by dx squared equals 0. And if the point of inflection goes that way, then it's still 0. Y equals x cubed has a point of inflection. Y equals tan x has a point of inflection, as you've probably seen from those graphs. Now, the last question. Given a cubic, y equals 2x cubed plus 3x squared minus 12x, find the position and nature of the stationary points. And I've put a little sting in the tail here and hence sketched the graph. Now we know it's a cubic, and you've probably done a bit of work about cubics can have two turning points. So this graph will probably have two turning points. One will be a maximum, one will be a minimum. Which is which and where are they? Okay. Now, it's very important here to keep the examiner aware of what you are doing. I've gone through this in a page and a half it took me to work out my solution. Now, pity the examiner. If you get something spot on right, it's easy to mark. The examiner goes, big tick, big smile, gives you 12 marks, say, for something like this. If you made a mess of it somewhere and you haven't made it clear about what it is you're trying to do when you did something, the poor examiner's sort of in a bit of a quandary. So, my rules, I always tell anybody I'm teaching, 3 things the examiner needs to know. What it is you're trying to do. So, the examiner needs to know you're trying to do the right thing. How are you going to go about doing it? So, how are you going about doing that thing? And then the answer. And that way you'll pick up method marks even if you lose the accuracy marks. Losing accuracy marks, though, people, I know my boss calls them silly marks. I object to that, silly marks. You know what? A silly mark, people think, oh, it's only a silly mark I've thrown away. Yeah, but it's a mark that's gone. And they're crucial marks. 2 silly marks could be your grade A star out the window, couldn't it? You know, don't just think, oh, the silly marks, it doesn't matter. Anyway, we start off, people say, it's all right for you, you're a maths teacher. Where do I start any question? What am I given? Well, I'm given, and this is always, for any exam question, I've put pen on paper, I've made a start. Now, stationary points is when the gradient is 0. So to find the gradient, I need dy by dx equals 6x squared plus 6x minus 12. So I've differentiated. You only get a mark for that. And then crucially, at the stationary point, dy by dx equals 0. So tell the examiner, why are you going to equate it to 0? And then you equate it to 0. 6x squared plus 6x minus 12 equals 0. Now, usually they'll factor out, you can factorize a number out. And here's my thoughts. 6x squared plus x minus 2 equals 0. Well, 6 isn't 0, therefore that must equal 0. So you can actually just write that. But you know what? Tell the examiner what you're on about, and then you can factorize it to x plus 2, x minus 1 equals 0, and solve the quadratic. X equals minus 2, x equals 1. Right, so I've now got the x values of the stationary point. the question did ask for the position of the stationary point, so it needs the y value. So go back. Now, if you've written this out here, if you think, how do I find the y value? Look at what it says. Oh, the y value is there. That's how I find the y value. So tell the examiner, if x equals -2, y equals 2 times -2 cubed plus 3 times -2 squared minus 12 times -2. And I've worked it out, it's a bit like Blue Peter, here's what I've done earlier. Y equals 20, right? And then, so that gives me stationary point of -2, 20. And then repeat that for if x equals 1. So if x equals 1, you'll notice in the notes I've given you a complete blank page to fill this in. If x equals 1, don't make a mistake here, just check the sign. Yes, it is 1. If x equals 1, y equals 2 times 1 cubed plus 3 times 1 squared minus 12 times 1. So y equals -7. So I've got my second point, which is 1 minus 7. So I've now got the position of the stationary points. Okay. I've got 1 minus 7 and I've got them at -220. Okay. Now, to find the nature of the points, you could draw the table and work out the gradients. And you would get full marks for that. But for the nature of the points, tell the examiner, nature of points, I'm going to use d2y by dx squared. Okay. Where's my starting point? Well, dy by dx is 6x squared. So I've already worked this out. So I refer back to where I did this. 6x squared plus 6x minus 12. And I differentiate again. d2y by dx squared equals 12x plus 6. There's a mark for that, so tell the examiner, look at that, give them the mark. If x equals -2, d2y by dx squared is, substituting -2 in there, I get -24 plus 6, which equals -18. The actual number is irrelevant. It's negative. So that is less than 0, negative. Therefore, -220, I've worked out that point before, remember, is a maximum point. Tell the examiner, well, I've worked that out. It's a maximum point. Okay. If x equals 1, d2y by dx squared equals, I've already worked it out there. I don't need to re-differentiate. I know some people have marked in the past where they've differentiated again and got, ironically, a different answer. It's 12x plus 6. So it's 12 times 1, which is 12 plus 6, which is 18. And that is greater than 0. Therefore, 1 minus 7 is a minimum point. Okay. And then it asks me to sketch the graph. So the examiner here is going to pick those up. The examiner would look at that and go, tick, tick. It wouldn't look at anything else. You've got it right. He'd have maybe a quick cursory look at that. But if you get that right, you're going to get full marks. And the sketch graph bit, right? I'm not going to have you watch it. It's here. Look, I've got it on the solutions page. We now know our stationary points. We now know the stationary points are there. Look, minus 220 and 1 minus 7. And actually, we've got another clue here. If x equals 0, y equals 0, so it goes through the origin, and I can sketch the graph. Okay, now there is one more type of question I want to show you, which is increasing and decreasing functions. But I feel I don't want to go any quicker than I've gone today, and that is now 40 minutes. There's a lot for you to digest there. The notes and the solutions are available for you. Okay, I've tried not to race too much. It will be worth you reviewing that, filling them in. Think about how I've set things out. Okay, it's not a mark scheme, that is a solution. What the examiner will be looking for. Okay, we will finish that off. I will show you one more question next week before we look at integration. So next week is integration, which is, I always find, less well understood. Pupils are less confident, but it's just like pupils are less confident with dividing than they are with multiplying. We introduce differentiation, we spend all that time on it, and then we say, oh, integration is just the reverse of it, and we never spend enough time on it. So I'm going to devote a full 40 minutes to integration next week. As usual, thank you for listening. If you want to make any comment about speed, suitability, we do value your comments because it does give us a chance to actually change what we do next time. So if you're happy, say you're happy. If you weren't happy, say what you weren't happy about. And thank you for listening.